Welcome to a screencast on acid-base reactions. Let's start by considering an aqueous solution of hydrogen chloride. And when we dissolve HCl in water, we produce an acidic solution, and HCl is an acid because when it dissolves in water, it produces hydrogen ions. Or more properly, hydrogen ions by themselves don't exist. If it's an aqueous solution, water molecule, at least one, will combine with it and make what's called a hydronium ion, H3O+. So H3O+ is more correct for what's in solution, but we often use H+ as a not quite correct but shorthand version for this. So HCl, when it dissolves in water, makes H+ and Cl- ions, and we can represent this in the following way. HCl gas dissolves in water and forms H+ aqueous and Cl- aqueous, or more precisely, we really should say HCl gas combines with water to make hydronium ion H3O+ aqueous and chloride ion Cl-. And this is a characteristic, this is what makes something an acid. It produces H+ or H3O+ when it dissolves in water. Now, of course, acids have other characteristics as well. They have a sharp taste. They turn litmus paper red. They have low pH, things like that. But what makes a thing an acid in general is that it produces hydrogen or hydronium ion in water. Now, on the other hand, let's consider an aqueous solution of NaOH or sodium hydroxide. And NaOH is a base. And it's a base because when it dissolves in water, it produces hydroxide ion, OH-. And we can represent this in a similar manner to how we represented the hydrogen chloride solution. And NaOH solid, when we add water to that, makes Na+ ions and OH- ions, and the hydroxide ions, formation of hydroxide ions in aqueous solution, that's what characterizes sodium hydroxide as a base. And in general, anything that makes hydroxide ions in water is a base, and it will also have basic characteristics. It'll have somewhat of a bitter taste, it'll have a high pH, it turns litmus paper blue, those sorts of things. Okay, now what happens when an acid is combined with a base? And we'll take an example of a strong acid, HCl, with a strong base, NaOH, and notice that strong acids are H+ and some other ion, in this case Cl-. Strong bases are going to be OH- and some other ion, in this case Na+. And as we saw with precipitation, when those are combined in one container, then the possibility exists for the positive and negative ions in solution to swap partners. And so the H+ from the acid could combine with the OH- from the base, and the Na+ from the base could combine with the Cl- from the acid, and potentially make NaCl and H2O. And it turns out that the H2O actually forms, and the NaCl, we are writing it here, them next to each other, but the Na+ and the Cl- don't actually stick together, they stay in aqueous solution. So we write it as a partner swap, but not all partners actually really recombine. Also worth noting, the NaCl that forms, water is of course water, the NaCl is what's called a salt. And to a chemist, salt doesn't just mean NaCl, it means an ionic compound. Now, this is a reaction between an acid and a base, so wait for it, we call it an acid-base reaction. Pretty creative. And in general, acids have H+, bases have OH- or produce OH-, and when they combine, they make H2O, and these are essentially, the H+ and OH- ions essentially neutralize each other, so we call this type of reaction also a neutralization reaction. And as a general rule, when an acid reacts with a base, it makes a salt, an ionic compound, and water. Those of you who take the second semester chemistry, you will see that this quote-unquote neutralization reaction is not quite as simple as we're saying here, but that will certainly suffice for now. Now, one other thing to note, this reaction can be written out in sort of expanded ionic equation form, as we did with precipitation reactions, by noting that HCl is a strong acid, so it's really H plus ions and Cl minus ions separated from each other. NaOH, same thing, but for a base, it's a strong base, so it's really Na plus ions and OH minus ions separated from each other. So I'm writing them as separate rather than combined. And then when they potentially swap partners, NaCl is actually an aqueous solution. The Na plus and the Cl minus dissolved in water don't stick together, so I write them separately. But the H plus and the OH minus do stick together to make H2O. And what we note is, comparing our reactants and our products, we have several substances, Cl minus and Na plus, that are floating around in solution before the reaction, floating around in solution after the reaction. In other words, they're spectator ions, and we can cancel them out to ultimately get to our net ionic equation, which is that H plus combines with OH minus to make H2O. And this is generally what's going to happen when we have a strong acid combining with a strong base and reacting with each other. Those are going to reduce to this same net ionic equation, H plus OH minus makes H2O. Also worth noting, a little more precisely, H plus should be written as H3O plus. So H3O plus OH minus makes 2H2O is a somewhat more precise equation for what happens. And that's it for the acid-base reaction screencast.